I'm going to talk about the MRI today. Now, MRI physics is basically a bit complicated. Now, the first thing to know is that MRI is based on the application of magnetic field to the human body. Now, the human body consists of a lot of protons. Basically, water has protons, fat has protons. And so what happens is that when an electromagnetic, these protons are roaming around in a random direction, as you can see here. So the protons are all in random direction. They are moving in random direction. They are spinning on that like a top on themselves and moving in random direction. Now, when a magnetic field is applied, these protons will all align in a one particular direction. This is the called the B0, or the primary magnetic field. Now, when all the protons are in one direction, nothing can be gained out of it, because there is no difference in the signals. All the protons are in one direction. Now, what happens is, while these protons are all in one direction, they spin like a top. And so this spinning of the top has a particular frequency, which is called as the Larmor frequency. Now, when we want to do something, to study something, we apply another frequency, which is called as the radiofrequency pulse, which will cause the protons to, which is generally in the opposite direction, which is called as the which will lead some of the protons to go into a higher energy state, which is completely opposite to that of the normal B0 magnetic field. As a result of which, the magnetic field which was in this direction gets divided between this and this direction, and occurs the vector is, and the resultant vector is in the transverse direction. So now the magnetic field is in the transverse direction. Now, once we stop, also at the same time, what happens is, when we apply this radio frequency pulse, the protons, which are all spinning in a one same direction but on their own axis, are out of phase. They will all synchronize in phase. They will all start spinning in the same rotation, that is the same Larmor frequency, in one direction, that is up this direction and down in this direction. Now, after we stop the radio frequency pulse, what is going to happen is, the protons are first going to dephase out of this into this phase back. So that is called the T2 relaxation time, and then from this phase they are going to this phase, which is called as the T1 relaxation time. Now, once the T2 and the T1 relaxation time you have understood, there is something called as the T2 star. The T2 star is basically nothing but the T2 and the T2 dash. The T2 I told you as that the time it takes for the protons to move from in phase to out of phase, which is called as dephasing. A T2 star is basically, there is certain variation, basically due to the environmental changes like inhomogeneity in the magnetic field and inhomogeneity of the human body and fat-water interface distortion, which causes a certain aberration, so that the actual time is slightly less than T2 and is called as T2 star, T2 hash, and the T2 star is just a combination of T2 hash and T2. Now, these are the various sequences. Now, what has seen in this section? In T1, we will, as water is for proton is a maximum amount is present in water. So once we apply a magnetic field, large amount of protons will enter into this particular direction. And then once we apply the radio frequency, a large amount of proton will enter the high frequency, high energy field, which they will take time to come back after the stoppage of the field. Also, so as a result of this, what happens is that since the time is taking is longer in T1, so the fat appears bright, because fat takes a shorter time and to reach back to its original state, whereas water takes a longer time. So fat appears bright, water appears dark. In T2, what happens is that the water molecules which are out of phase will take a shorter time to get dephased, which are in phase will take a shorter time to get out of phase, and that is why water appears bright and fat takes a longer time to get dephased and fat appears dark, whereas flowing blood will appear as dark. This is the one thing which you have to remember separately. Now, flare is fluid, attenuation, inversion, recovery. This is nothing but that basically it is just T2, where only thing difference is that the non-free flowing blood appears as bright, Okay, so here the what happens is that this will help us in differentiating edema from blood, basically from blood in the vessels. What happens is edema is non-free flowing, so it will appear as bright, whereas CSF and blood will up, which is free flowing, will appear as dark. Now, what is GRE? GRE is gradient echo, which is also similar to T2 star or substance weighted imaging, is nothing but basically if there is some substance like metals, which they will appear as dark. So blood which has iron or calcium and other iron metals in siderosis and on hemochromatosis will appear as dark. Diffusion weighted imaging is for ischemic stroke. This is basically based on the fact that once water diffuses into the cell, the Brownian motion reduces. So what happens is during ischemia, there is the cellular cytotoxicity due to loss of oxygen. As a result, the cells have more amount of osmolar metabolites, which causes blood to flow from extracellular space to intracellular space. As a result, the extracellular fluid decreases. If the extracellular fluid decreases, the amount of free water, which will have a large amount of Brownian motion, decreases. As a result, diffusion weighted imaging, that part will appear as bright. Now, fat suppressed is basically an image. ADC, what is ADC? ADC is nothing but diffusion weighted imaging minus T2. Now, diffusion weighted imaging, you will see that it is a combination of, it's just a T2 image with a differentiation between each extracellular fluid and intracellular fluid. Now, sometimes we will have difficulties in understanding diffusion weighted imaging because the background will be a T2 image. So once we subtract it, we will get only the diffusion weighted, only the extracellular space, and that is called as ADC. So it is very important to check out the ADC while checking out the diffusion weighted images. Fat suppressed is nothing but basically fat appears bright on T1 and CSF is also fat appears bright on T1 and in diffusion weighted images, the even the or the extracellular fluid will appear bright. So to differentiate the fat from the extracellular fluid, fat suppressed images are used. Gadolinium is a contrast medium, which is technetium-99 gadolinium diethyl triamine pentaacetic acid, and MR angiography is based on the technique that two techniques called time of flight and MOTSPA. MOTSPA is nothing but multiple overlapping time slab acquisition. Now, time of flight is basically nothing but basically what happens is that when the magnetic field is applied, the magnetic field will act a short amount of radio frequency pulses are continuously applied, then the tissues will get saturated with the magnetic pulse and will stop showing a signal. But what happens is that the new blood which keeps on coming in with the new RBCs are not saturated. As a result, they will appear bright, and that is called as time for flight. MOTSPA is nothing but acquiring multiple time of flight in thin slabs over a 3D image. MR venography has similar principles like MR angiography, and CSF flow study also has similar principles like MR angiography. These are mostly academic purposes. MR spectroscopy is a totally different technique in which acetylcholine, choline, and adrenaline, all these things are measured on a spectroscope, and these are overlaid over an MRI image, and we are trying to see whether there is an increase or decrease in the amount of these materials in a particular lesion. If the lesion has generally a higher amount of non-adrenaline, then they are generally prone towards the neoplasm, whereas if they have high amount of choline or lactate, then there is generally a higher chance of abscess. And then CSF flow studies, and then as I said, and then comes the functional MRI. Functional MRI is basically the patient uses MRI. At the same time, the electrodes are placed in the brain, by which the certain areas of activation are checked on the MRI. By the accumulation of metabolites there, and then those areas are tested for functionality. MR perfusion study is again another study which will help in the amount of perfusion of contrast into certain tissues, and based on that, the cerebral blood flow and cerebral red cell cerebral blood flow volume is checked. So these are all the techniques. Apart from that, there are other techniques like flash, and then there is spin, and these are way beyond the understanding for understanding MRI at this level. If you like my video, please like or subscribe.